It's amazing what geology mapping we can do with Earth terrain and some JavaScript. Here's the world, and I've got a couple of examples here that I've set up. The first one is from my field area in northwest Scotland. This is famous for a lot of thrust structures, and you can see that the geology outcrops are draped over the terrain, so we can see quite easily how this actually looks in 3D. And we can also put some labels on so we know where we are. Ben Mora Sint, for example. We can put some lines on, such as faults and thrust faults. So this is all fairly standard. We can do this. But what I've added is the dip meters. So these are all the dip meters taken in the field, and also some projected around the thrust faults. So that means we've got quite a lot of information here, and we can imagine how is this thrust fault going to, what is its geometry in 3D? So from here, we can actually select, for example, the Benmore thrust, as it's called, and then we can create surface using those dips. And we've got a dialog box comes up here, and I'll just set one of these things just to quickly show you how this thing works. So it's immediately generated a surface. Just take this out of the way so we can have a look at it. So that was a quick example. And to generate this information, we can digitize labels, digitize lines, digitize polygons. I'll just do one for example here. Supposing we think this is a particular unit, we can add a unit. Let's just pretend this is a dike. So we can digitize some sort of polygon based on field observations and based on interpretation of the topography. And then the important thing is this will be saved to a database. So actually anybody can access it anywhere in the world. And you can work on it in collaboration with other colleagues from across the world. It's possible to view these surfaces under the ground. If I switch on surfaces now, you see this is one that I created earlier, as we say. Switch off the dips for the moment so we can just see the surface. That's the Benmore thrust. And we can see here that it's actually clipping the top of the mountain here, so that's probably not right. So we need to do some adjustments. So I'll now show you another example that I've set up. That's Mount Everest. We've all heard about that. So here we are on Mount Everest. I'll switch on the geopolygons. That's a geopolygon. So here we have another thrust sequence where, because India's collided into Asia and created some huge thrust sheets. And the red here is a granodiorite, and here's the famous yellow band on Mount Everest. And there's actually a slide, a huge slide along that goes around the mountains here. Just put the labels on. Everest, Lhotse, geolines. So this black line is the slide. And the first thing you notice is, because we've got the 3D geometry of the mountains here, we can see that it's not flat. It's by no means a plane. So again, we can explore the geometry of this slide and just see what its possible geometry is. And this is one of the most useful features. This is how to add a dip and a strike plane for a particular unit or a surface. So here we're going to add another plane for the slide. So we go to digitize dip points. So when we click here, for example, the dialog comes up and we can put the dip angle, say 45 degrees, and the azimuth say 30, and the influence is just like the sort of area that it's going to be scaled up to, and it's press apply. So now we see a little plane comes up. It's quite small, we can make it bigger. So you can see that this is, we can visualize this and we can match it up in this example to the boundary between the pink and the green. So that's much closer now. I've adjusted it. You can see that it's lining up. Probably, perhaps the dip's a bit steeper, make it 55. Apply. Okay, so now we've got a point that sort of roughly matches the outcrop information that we have. Of course, you could also do this in the field, but it's pretty difficult to do this halfway up Mount Everest. And then we can save that. So it'll be saved, and then we can use it. For example, if we want to generate a surface, we can use it, and it will then be part of the information that will be applied there. See, so it's honoring those data points now. All the black are all the data points, and they can be projected up and down dip. In that can be adjusted. So it's a pretty flexible system. And as we say with one I generated earlier, there's actually the two thrust features here. So that's what we can do, and I think this is useful particularly in remote areas, and again where you've got more than one person working on a project, because behind this there is a database, so all of these features can be assigned. And at the moment it's completely open access. Anybody can use this, so don't be frightened. You can go and use it, and then on this second page is all the information about it, and it would be nice if you do want to use it, just send me a message one way or the other, and then we'll see how useful it is over the months to come. So thanks very much for listening, and good luck with it.